Hello, 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 everybody, and welcome back. Welcome back indeed. We're looking at the grade 10 Cayley paper. That's the multiple choice contest put out by the Center for Education in Mathematics and Computing at the University of Waterloo. And we're looking at the 2001 paper. And question number 16 is what we're going to tackle in this video. How many integer values of x satisfy x minus 1 over 3 is less than 5/7? And 5/7 is less than x plus 4 over 5. Okay? So it looks like we have a single giant inequality here, but really what we're going to do is we're going to break it down into two inequalities. And we can rearrange each of them to solve for x. So we'll grab our pen and we'll grab a fresh sheet of paper. So we want x minus 1 over 3 less than 5/7 less than, I think it was x plus 4 over 5. Before we go any further, let's make sure we have it right so we can manipulate it properly. X minus 1 over 3 and x plus 4 over 5. We're looking good. So really we're looking at two inequalities here. We got this one over here. And we have this one over here. We'll make it lavender. I don't use the lavender enough. And we've got this inequality over here. So 5/7 over x plus 4 over 5. Now what we're going to do is we're going to solve each of these in turn. And this will give us a range of x values. And then this one will give us a range of x values. And we just see which ones they have in common. Okay? So we'll take the first one. X minus 1 over 3 less than 5 over 7. I'm not a big fan of fractions, so what I'm going to do is I'm going to multiply by 3 times 7, the bases, get rid of them. So I'm going to multiply by 21 on both sides. So that'll give me 7 over x minus 1 less than 15. So that means that we'll have x minus 1. Actually, that's silly. We'll just multiply 3 on both sides. We're just trying to isolate x. So x minus 1, and then we'll do less than 3 times 5 over 7. When I multiply by a positive number, the sign of the inequality does not change. Then I can add 1 to both sides, so x is less than 3 times 5 over 7 plus 1. Let's just clean this up. 15 over 7, and then we'll change 1 into 7 over 7, so we get a common denominator. That's 22 over 7. Okay, and that's a little over 3. That's sort of, I think, 3.14. So x less than or equal to 3 solves the blue inequality. Now how about the lavender inequality? Again, we're just trying to get the x all alone on one side, so we'll multiply through by 5. The sign of the inequality doesn't change. We get x plus 4 here. And then we'll subtract 4 on both sides. Now, I want a common denominator of 7, so I'm going to change it to 28/7. So that's negative 3 over 7 is less than x. And that's just a little below 0, so x being greater than or equal to 0 solves purple inequality. Okay. Now the reason I was able to round to x less than or equal to 3 and x greater than or equal to 0 is because we are specifically looking for integer values. Okay? I might have wanted to stress that a little earlier, but we're looking for integer values. So getting the 3.14 here, well, the biggest integer that will solve that is 3. So any integer less than or equal to 3. Now, to solve both inequalities, we need x values that solve each of the inequalities. So we need x between 0 and 3. And we're asked for how many integer values? So that's 0, 1, 2, 3. I'm listing them out just so I can very easily count them. So there's 4 values that work. Okay, and 4 is answer number E. Okay, if we wanted to, we could double check by plugging in some of these x values and making sure that both sides of the inequality work. Okay, that all the inequalities work out. I'm not going to do that right here, but it's still something you can do, and it's always a good idea to have these checks on hand, these little ways in your mind that, oh, I'm given some x values, I can actually plug them in and make sure that I do have the right answer, that I didn't screw up somewhere. All right, so that gives an answer of E, and that was question, was that 15? No, that was question 16. So in the next video, we're going to take a look at question number 17 on the 2001 Cayley paper. So hopefully you'll join me for that one, and I'll see you in the next video.